An important concept is for us to think about how we measure our heat changes and what kind of units that we're going to use to do that measurements. So the first one is a calorie, and this is the energy it takes to heat 1 gram of water 1 degree Celsius. So this is a definition that is classic in terms of what we use, and you will see this come up quite a bit. In one particularly common place you will see the term calorie is when you look at your food packaging. But recognize that the calorie that is on the packaging is actually with a capital C. And the capital C is actually a K-calorie. So make sure you do understand that in terms of thinking about something that is more real, that you might encounter every day. But the most common unit that we're going to use is actually in the SI unit, and that's our joule. So in our joule, 1 joule is going to be equal to, the units for that is 1 kilogram meter squared per second squared. So that is our typical SI unit that goes back to to mass and speeds. So we will go ahead and use this joule term probably the most, but you'll also see calories come up on occasion. But we're going to go ahead and calculate Q in a couple of different ways. So our Q is how we are going to measure heat in our reactions. But we need to go over a couple of different ways of calculating heat. So we can calculate heat using a specific heat capacity. And this value is actually an intensive property. So bringing back from the earlier concept of extensive versus intensive, this value doesn't matter how much material or matter's there. So we can use a specific heat capacity. We're going to use a lowercase c from this. Just so you know, if you talk to a previous student of Gen Chem 1, you will also see this as a lowercase s for specific heat capacity, but our textbook uses a lowercase c. So the heat using a specific heat capacity can be calculated by measuring the mass times the specific heat capacity times the change in temperature. So this is our mass, specific heat capacity, and this the delta T is T final minus your T initial. So the final temperature of the material and then the initial temperature of this material. And that makes sense for this, the specific heat capacity. The units for this is going to be joules per gram degrees Celsius. And that makes sense because our mass will be able to cancel out the grams over here, and our temperature, change in temperature, can cancel out our degrees Celsius. So then we get joules at the end for our Q, which are our SI units for measuring heat. So make sure you check your units. So one thing that comes up quite a bit, your mass may be in some other unit. So it may be in something like kilograms or milligrams, and then you'll have to convert it based on whatever your value, your lowercase c is. And same thing for temperature. It's actually most common to use things like in Kelvin, but since we're taking a difference in the temperature, degrees Celsius also works quite well for these kinds of calculations. We can also use what we call a heat capacity. A heat capacity is an extensive property. And you will most commonly encounter the heat capacity as a capital C. And this will be like the heat capacity of an object. Your textbook goes really detailed into this. Like, for example, the heat capacity of a small frying pan is different than the heat capacity of a large frying pan, just because there's more mass in a large frying pan. So, but what we will typically use is this heat capacity will come into something that we are going to call a bomb calorimeter. And you will see the heat capacity of that object. And you know you have a capital C by looking at the units. The units for this are going to be joules per degree Celsius. So notice in there isn't any mass because it deals with a specific object. that we are using. So the Q to calculate for this is going to be our capital C times delta T. So we get our joules per degree Celsius here, and we get our T final minus our T initial. So based on these couple of definitions, we have plenty to calculate in terms of our next topic, which is going to be calorimeters.